Hi everybody. Today's lecture, discrete-time Fourier transform. And let's just me remind you by the last lecture. Last lecture we did continuous time Fourier transform. It means that we perform Fourier transform to continuous signal x of t. Today we are going to perform Fourier transform on discrete time signal. Well, the discrete time signal to do the Fourier transformation, that's the equation we're going to use. Of course, once you do in discrete time, you use summation instead of integration. So you have the summation from minus infinity to infinity, and x of n, that's the discrete time signal or sequence, multiplied by e minus j omega. And just to distinguish between the continuous and discrete, we used here omega instead of small or lowercase omega. We use the upper case omega, n instead of time. So it's, you see, it's just very similar to the continuous, but just you made it for discrete. So use n instead of t and capital omega instead of small omega. And the second one, it's the inverse. If you have the Fourier transform with discrete signal x of omega, how you can get back the sequence or the discrete time signal x of n. All right. Of course, when you do any Fourier transform, it means that you want to find the components of each frequency, its amplitude, and its phase. It means you want to find the spectrum. All right. So let's just take an example and see how can we perform Fourier transform for discrete signal. All right. Well, that's the signal. It's defined by x of n is equal 0.5 power n. So it's like that's like an exponential function multiplied by u of n. U of n, it's the step. U of n, it's the step. So just let me write that. And when you multiply any function by unit step sequence, it means that this function 0.5 power n will start from n greater than or equal 0. And before that, the function will be 0. That's the meaning when you see any function multiplied by unit step. Well, the first question is plot the signal using Matlab. Just, we want to plot this function or this signal 0.5 power n un. How you do that? It's just as a practice. So how you plot a sequence, all right? So let's just go to the Matlab. As we know, when you write any program, you should start with clear. So you clear the memory of any calculation or anything you had it before. It doesn't mess up your program, new program. And CLF is just to clear any figure, so you have fresh figure. All right. Always make it a habit. Just always you write these two commands. Now, I want to remember that we want to sketch the function or the discrete signal x of n 0.5 power n u n, and it means that it's equal to 0.5 power n when n greater than 0 and 0 when n less than 0, and n it takes integer, so it means 0.5 power n will be divided at n equals 0, 1, 2, and so on. All right. Well, to sketch this function, we're not going to sketch till infinity, so we'll pick a period that's reasonable. So I picked here the period. I said n1 from minus 5 to 0. Why I did that? Because if you sketch this function, you have here 0, you have 1, you have 2, you have 3, you have 4, you have 5, whatever you want to do. You can continue. All right, you can continue till 10, I suggest. And then you have to get something in the back, minus 1, minus 2. So I said, or assume, I'm going to sketch the function from minus 5 to 10. So that's the period where I'm going to sketch this function. Well, I'm going to divide it to two periods. And this period to the left, I call it n1. So n1 starts from minus 5 till 0. That's what you see here, from minus 1 to 0, and the step, of course, 1. Minus 5, it means you have, what does it mean? It means that you have here minus 5, minus 4, minus 3, and so on till 0, all right? During this interval, the all signal values are equal to 0, all right? So you want to give it 0. So now I will say x1. What does it mean x1? It means, maybe you ask, but you have x. Why you call it x1? Well, I'm going to divide it into two sequence. One here, it's called x1, and one to the right, I call it x2. So x1, the one to the left of the 0, it should be equal 0. So you cannot just write 0. Why? That's very important, and let me just tell you why. When you have time or sequence, and let's say you have minus 5, minus 4, minus 3, minus 2, minus 1, 0. So how many elements do you have in this vector? 1, 2, 3, 4, 5, 6. So you have 6 elements. All right. So when you sketch the x is equal 0, you cannot just write x1 is equal 0 like that. Why? Because 0 here is one element and n 6 element, so Matlab will be confused when you ask him after that to sketch. So always you put in your mind that the vector you're going to sketch with, like you are going to want to sketch x1 versus n, for example. Or you want to have values for x1 versus the values of n. If n has 6 values, x1 has to have 6 values too. The same thing. So how can you guarantee that? So the first thing, you're supposed to calculate the length of the vector n. All right. And remember that this is, a row vector. What does mean row vector? It's only one row, 6 columns. So this is 1 times 6. That's the dimension of n vector. So the same thing, x1 should be the same thing. 1 row, 6 elements. Okay, 1 is okay, but how do you know the value 6? How you get it? Well, use the command length of n1. So when you use length of L1 of n1, that will give it, Matlab will calculate the length of n1. It means the length of vector n1, it will put it 6 here. So when you write x1 is equal 0s, 1, 6, it's the same length of n1 because n1 is 1 row 6 column. That's why I write it this way. So that's a very important point. Keep it in mind. Now I'm going to move to the second interval from 0 to 10. So I define it. n2 is equal 0 to 10, and the step is 1, 0, 1, 2, 3 till 10. The function of x2, it's the normal one. It's 0.5 power n. So that's what you're going to do. x2 is equal 0.5 power n. Now you will ask, how can you guarantee that x2 here, when we'll do it like 6 element like the x1? All right. When you make any operation like multiplication or division or power here, like here the exponent, you put 0 before that. You put 0. Dot. I'm sorry. Somebody asked why. All right. Let me tell you about something. If you have a vector like that, and this vector is like, say 1, 2, 3, and you want to multiply it by another vector, let's say 4, 1, 2. When you multiply it, you cannot multiply mathematically because the number of columns should be the number or equal the number of rows in the second one. So this doesn't work in math. In math, you should 1, 2, 3. You have then this one should be like 4, 1, 2. Then you multiply. You will say 1 times 4 is equal 4. 2 times 1 is equal 2. 3 times 2 is equal 6. And then you add it, and you get the value of 12. Well, in Matlab, when you are doing that, you got two options. It's either to make this transpose, or it means what does it mean transpose? Meaning you flip it to that, or there is something easy. If you want to multiply element by element, you don't do this just the multiplication symbol here. No, all what you're supposed to do is 1, 2, 3, and then this is the multiplication. Before that, you put dot. When you put dot in Matlab, Matlab will understand you want to multiply 1 by 4, and you want to multiply 2 by 1, and you multiply 3 by 2, and you add. You will do the same thing you did here. That's why you always use dot, before any operation, multiplication, division, power. So that's what I did here. What I did here, I just I put here dot power. All right. So 0.5 power into it's changing from 0 to 10. All right. So that's, we'll calculate. Now you have two interval x1 and x2, and you wanna collect them. So what you do, you have n, also n1 and n2, put them in 1. Why you put them in 1? So it will take everything. N1, if you remember, start from -5, so it would -5. And then by itself, it will continue. -4, continue till 0, 1, 2, to continue up to n, the last element in n2 is equal 10. In this way, you take the whole interval that was divided into two sub-intervals. X, the same thing. You have x1 and x2, just put them together. It will put them just next to each other in one row also. And you are sure now the number of elements in n equal the number of elements of x. And now we sketch it using stem, because you wanna sketch discrete signal to use stem. And this is in x-axis, or the horizontal axis, that's n, and that's the vertical axis x, that's defined here. And I'd like to make it clear when you print it, so I say the line width is equal to make it thick line. If you don't put this one, you get the normal, the default, which is skinny, a little bit skinny line. And the rest, I'm not going to, you know how you make the label of x and limit. But it was important to explain that. Once you do that, what you're going to get, you are going to get this. And you should try it to make sure. Now I sketch it. It just was like, this question just, to make sure that you know how to sketch discrete time signal. Now we'll go for our subject today, express discrete time Fourier transform in the simplest possible form. All right, now let's just do it. First, you have to know the formula. Well, the formula, it was given before, and I'm going to rewrite it again here, x of omega. That's the Fourier transform, and we have sigma from n equal minus infinity to infinity, and the sequence x of n and e minus j omega n. That's the Fourier transform of discrete. All right. How you do that? Well, x of n, what's x of n? X of n, I will just replace now x of n by the expression was given in the problem. It's equal to 0.5 power n, 0.5 power n un. What does it mean, un? Un, it means start from 0 till infinity. So you can do that. All right. It means you can erase it, and you will say, I'm going to start not from n equal infinity. I'm going to start from n equal 0. All right, great. So now I want to multiply these two things and then just find the result. All right. That's what we're going to do. You multiply 0.5 power n and e power minus j omega m. So you have n as a common factor. So you can write this is sigma n equals 0, infinity. And you have 0.5 and you put here e to the power minus j omega and all power n. You can do that. All right. All right. So once you do that, it's like, you remember, this formula when you say, if you say, what is the sigma from n equals 0 to infinity, a to the power n. So if you do that, a power 0 is equal 1, all right, and plus a squared, and so on. And we say that if a magnitude less than 1, so you may approximate as 1 over 1 minus a. True? Now this is my a. So now I can write x of omega is equal to, that is a, so 1 over 1 minus a, and a is equal 0.5 e power minus j omega. So that will be your answer. All right, this is your answer. You can, of course, if you want to simplify it more, you can simplify it. I will leave it for you as exercise. You can, of course, e power minus j omega, you can find its magnitude and the angle and do that. But I'm not going, to go through this now. I'm just going to the second one because this is correct anyway. Now plot the amplitude and the phase spectrum for the signal, because this is always the objective by any Fourier transform. You want to find the amplitude for each component, and you want to find the phase for each component so you can do the design of your system. Well, how you do that? I'm going to do Matlab. Of course, you can do it by calculation, you know. I will leave for you to just try to do how to do the calculation. And then if you have any problem, you can ask me and I can show you how you do that. It's just, I mean, complex number. If you know complex number that we review, you can do it. But I'm just going to do it using Matlab. And I'm going to show you the program now. How can you do that? All right. This is a Matlab to sketch the spectrum. Well, first, I mean, we'll start clear in CLF as usual. And now the omega from minus pi to pi, and the step is 0.1. You're increasing by. And always when you do the spectrum for Fourier series, for Fourier transform for discrete, you can do it from negative pi to pi. Negative pi to pi. Why I'm saying so? Because whatever you are going to sketch here, the result is going to be repeated if you do it different pi. Well, it's a good exercise for you if you can rewrite the program again and just increase this. I mean, instead of from minus pi to pi, we'll make it from minus 3 pi to 3 pi. Try to do it. So we can just write an omega is equal to minus 3 times pi. Make the same step, 0.1 is good, plus 3 times pi. And see what you get, all right? To make sure that is really repeated. It is repeated. All right, so now I want to find, I define x of omega. X of omega, I found it. If you remember, let me show you. That's the x of omega. We got, yes, that's what we got. 1 over 1 minus 0.5 e power minus j omega. So that's what we are going to write in the program. And here, 1 minus 0.5 exponential minus omega times I. I, it means j, or the imaginary part. So I just type the expression. Remember again. When you do the division, I put the dot before. You know why now? All right? You got to do the dot all the time when you have the vectors. Now you have the expression for, that's this expression corresponding to x of omega, that you want to find its amplitude and its angle. The amplitude is easy. Call it n equal the absolute of x, because x is a complex. This x is complex, all right? So what you're supposed to do, find the absolute value. So let me just write here, x in general is complex number. And you know it has, I mean, already I here, which is j. So to find the magnitude m, you just find the absolute value. It will give you the magnitude. If you want to find the angle, call it theta. So theta, it's equal the angle of x. And use just the word angle. Matlab understand that, to give you the angle. But remember, this angle, when you use it in Matlab, is going to give you n radian. All right? It doesn't give degree. All right. Now let's continue. You are done. Can you believe it? It's just very easy. You put the interval you want to sketch. You want the equation of the x. You want amplitude. Now you're going to sketch. You want to sketch it in 1. So what you're going to do, you're going to divide the screen into 2. The screen of Matlab to sketch 2. 1 and 2. You have 2 rows. That's row number 1 and row number 2, right? So you have 2 rows and 1 column, all right? So 2 rows, 1 column, and if you put 1, you are in the 1 in the top. If you make 2, 1, 2, so 2, this revert to the second screen, the second part of the screen. So I'm sketching for the first, the top. I'm going to plot the omega at an x-axis, all right? That will be like that. That's be like omega. And this one will be the magnitude. There is one. And you do the label and all the things, and the limit. And now we are going to subplot for the second screen. You are going to sketch. Oh, here I'd like, for me as a personal thing, for you, you can do whatever. Whatever I got theta, it was radian, if you remember. Theta was radian always Matlab working with the radian. I multiply it by 180 divided by pi. So to change it to degree, because I'd like to sketch in degree. So it will sketch like that's omega and that's theta in degree. All right. And here you go. And then I did it. And that's the amplitude. So you can say many things about the DC component at omega equals 0. This is the highest one, is equal to, and then every time the omega increasing, you will see that the value of the amplitude of the component is decreasing till it gets in higher harmonics. The amplitude is almost 0. For the phase, your DC component, of course, doesn't have any angle shift, so it's 0. It's at 0 here. And every time you're increasing the frequency, then the angle is getting as a magnitude. It's from between minus 40 and 40. All right. So it's getting like, from 0 to minus 5, minus 10, so on till it reaches the maximum, which is between minus 40 and minus 20. And then if you increase more than frequency equal 1 radian per second, the shift will be decreasing again. So that's the meaning of it. I hope you understood it, and try redo the example, and you have another extra example in the handout. All right. Till then, see you soon.